All right, thank you for watching this video. I want to make this pretty quick. This is going to be over a few examples of inequality scenarios. So some story problems, except for they're not really problems. You don't have to solve anything. So these are examples of not actually solving a inequality story problem, but more of looking at a scenario and setting it up with an inequality. So let's get into it. So the first thing that is important is our 4 inequality symbols. So I'm gonna write these off to the side. We have a less than, greater than, less than or equal to, and a greater than or equal to. So those are the symbols that we have. And for my students, I tell them for the variable, just pick X. But for the sake of this, I am going to make it a little more, I'm gonna pick a variable that makes sense to the story problem. So when cooking a turkey, you should cook it until its internal temperature is between 160 and 167 degrees. Oof, spelling error, degrees Fahrenheit. So can we create an inequality to represent this temperature that a turkey should be cooked to? Because it's a range, right? It's a range. It's not cook it to 160 and call it good. It's between 160, 167 degrees Fahrenheit. So I'm going to say, let's say T for temperature needs to be in between 2 temperatures. So the more negative, or some students view it as a smaller, the less positive number, but on a number line, because that's what inequalities work with, are number lines, 160 is to the left on a number line. So we're going to put 160 on the left side. I'm going to put 167 on the right side. The advantage to this is the arrows, your inequality symbols point towards the left always if you set it up like this. The other way to think about it is your inequality symbols should, when you set up an inequality like this, a compound inequality that is in between 2 numbers, it's an and inequality, then your inequality symbols should be pointing towards the smaller number, the more negative number, the number on the left on the number line. So they should be facing this way. The thing is, we have to decide, okay, it's in between those 2 numbers. So it could be 161 degrees, could be 160.5 degrees, could be 166.9 degrees. What we have to decide is, can it be 160 degrees? And can it be 167 degrees? That is, do I need to put little dashes below it? Can it be equal to these temperatures? So you have to look at, what's the word between mean? Between means that it includes it or that it doesn't include it. And I would say that between means it does not include it. So they are not equal to 160, which now might not make sense. Like if I was to cook a turkey and it said 160 degrees, I'd be like, oh, good enough. Made the temperature. Not going to get sick if I eat it. It's cooked all the way through. But for the sake of how this is written, between means that it does not include. It is between, not including. So that would be the answer. This would be the inequality. Let's go on to the next one. You need at least 12 players to have a football team. So can we create an inequality that represents the amount of players that you can have on a football team? So at least, what's the smallest amount? Now I know there's 8-man football, I think 8-man football is a thing, but usually you got 12 players on a field. I think I'm being accurate about that. I played football once upon a time. You have 12 players on team. So if 12 players is the least, and let's say we're talking about players, so P, is P going to be less than 12 or is P going to be greater than 12, the amount of players we want? It's going to be greater than 12. But it's also going to be equal to 12, because if I have at least 12 players, we can play football. Nobody better get hurt. Nobody better run out of gas, but we can play football with 12 players. No subs. but it could also be greater than 12. You can have 15, you can have 20 players, you can have 30 players. Now, is there realistically probably a cap on this? I mean, you're not going to have 100 to 1,000 players on a team. However, I don't know if there is a cap. I don't know if there's a league cap on like saying you can't have more than 50 players on a football team. I don't know. But this means that I have at least or more than 12 players. All right. So that would be an answer for this one. That would be an inequality that represents the amount of players you can have. And now this is also assuming that we're talking about whole numbers, because we're not going to do decimals and fractions and irrational numbers when we're talking about human beings. But for the sake of this, that works. Okay. It is predicted to snow 4 to 13 inches. So can we create an inequality that represents, let's say, S snow level? So again, we're going to be in between two numbers. We're going to be in between 4 and 13. So we should be pointing towards the 4 because that's the smaller number. It's on the left. It's more negative. Now we have to decide, does this mean that it can be 4 inches and it can be 13 inches? Let's read it again. It is predicted to snow 4 to 13 inches. So it's predicted that there could be 4 inches all the way up to 13 inches. So this does include. That is the difference between this one and the first one. This one was in between the two numbers. This one is from that number to that number. So it includes those numbers. So that would be this answer. A fishing boat has a weight capacity of 800 pounds. So weight capacity means maximum. So if we're going to have 800 pounds, everything else is going to be less than or equal to that. Because weight capacity means we can have 800 pounds, but if you exceed that threshold, our boat's going to sink. It's going to get a little topsy-turvy. All right. But weight capacity wise, we can have up to 800 pounds. So everything over here is going to have to be less than or equal to 800. So what do we have? So we got some fishing gear. That's 40 pounds. So we got 40 pounds of fishing gear. Plus the average weight of each fisherman is 160 pounds. So plus the average weight of each fisherman. This is a key word that shows up in a lot of story problems when we're talking about linear stuff is each. That means every single one. So each fisherman, let's say F. Now I have some students that are trying to solve this. And they're just writing that inequality. I would accept this. This is the inequality. This inequality represents this problem. It represents a scenario of how many guys or gals can we get onto a boat if the average weight of each of them is 160 pounds and we got 40 pounds of gear. Obviously, at a certain point, we're going to be like, hey, dudette, we're at capacity. You're going to have to hang out on the side and fish off the bank because we're maxed out. Nobody else is getting on board. That's what this represents. It's got to be less than or equal to 800. So I have some students, though, that are going through and solving, which is totally fine, too. So minus 40. What do we get? We get 800. 760 is greater than or equal to 160F. If I write this over here, 760 greater than or equal to 160F, divide by 160, divide by 160, and I get F. See, now this is where a situation happens. I'm gonna laugh if this works out perfectly. 760 divided by 160. 4.75. Now we're talking about fishermen. We're saying we got 0.75 of a human being. Does that work? No, it doesn't. It does not work. So, but is this is the solved inequality. This inequality represents this problem. Now, what I would like, this is technically not wrong. You solved it. You did solve it. But thinking in the context of the problem, which I've been glad to see a lot of students have, at least my students have done this, and you should do this, is you need to go, like, once you solve it, go back to the problem and think about it. Can I have 0.75 human beings? No, you can't. Can't have 0.75 human beings. Doesn't work. They're not alive. You're missing a quarter of them. It's not good. Take them to the hospital. So you need to think back to the context of the problem, and some students have a misconception of they round up because they're so used to rounding up. So, okay, 5. No, you can't round up. If this is the maximum that you can have is 4.75, what is the actual amount of fishermen you could get on the boat? It would be 4. Because it's saying that if I get 5 people on the boat, we're getting topsy-turvy, we're sinking, we're over capacity, no good. But if I have 4, 3, 2, 1, or, and this is where another situation is going to come in, can't we have 0 people on the boat? Can't we have 0 people? Shouldn't there also be a cap over here of we can't have negative people? So there should actually be a cap of 0 over here. So we have anywhere from 4 to 0 human beings. 0, 1, 2, 3, 4. That's the maximum amount of people with this gear that we can get onto this boat. We can have 4 fishermen and 40 pounds of gear on this boat if their average weight is 160 each. Hopefully that makes sense. And it should make sense, the 0. We can't have negative human beings. No negative human beings. Not possible. There's certain things you can't have negative, no negative time, no negative weight, really no any negative measurements, no negative distance, can't go negative distance. There are some measurements like temperature. You can have negative degrees Fahrenheit. You can have negative degrees Celsius. Kelvin, Kelvin, I think that's the one that bottoms out at 0, and that's absolute 0. Nothing gets colder than that. I think that's in Kelvin, if you ever heard of that. But anyways, let's move on. So that would be, I would accept the 2 right answers that, in my opinion, would be acceptable would be this initial one or this one. Either you just wrote the scenario, you didn't solve it, which is fine. You just wrote an inequality that represented it. That's okay. Or this one where you did solve it out in the case of human beings, because even though that's the answer, we're not going to get there. It's going to top out at 4. Okay. Let's move on. I'm trying to scroll with my mouse. That's not going to work. I got to move it up and down. All right. You have $100 and want to get $20 worth of food and some games on sale for $30. So you got $100, which means we can't spend over $100. I mean, if maybe you have a credit card, but you got $100. All right. You got a $100 bill, got a Benjamin. We're going to be less than or equal to that because we are going to spend less than $100 or we're going to spend $100, right? Now, how much money are we going to spend on food? We're going to spend $20 on food. Plus, how much are we going to spend on each game that we could potentially buy? $30. And I'm going to put G for games. All right. So I would say again, what is, and that's not the least amount of people, that's the least amount of weight. Like you can have 0 pounds on the boat or 800 pounds. That was my bad. I explained that incorrectly. 0 pounds on the boat or 800 pounds. And the same thing here is we can spend $100, but what's the least amount of money we can spend? $0. We can spend $0, not buy any games. That's one way to think about it. So if we were to solve this, I don't know if this is going to work out right. Maybe I'm in over my head. Subtract 20, subtract 20, subtract 20. Yeah, I don't like that because you're going to get a negative number over there. Let's just, because we're not talking about games, we're talking about money. You can have negative money. You can spend less than, what am I doing? let's just go with it. We're gonna get 80 equal to 30G less than or equal to negative 20. I don't know how I feel about that negative 20 being over there. Divide by 30, divide by 30, divide by 30. 30 goes into 80, $60. So, and then you would get 20/30ths. So 2.6 repeating is greater than or equal to G is greater than or equal to negative 0.6 repeating. Obviously that doesn't make any sense, this over here. And that's just because how I set it up in the beginning. You can't have negative games. So it's going back and thinking about it in the context of the problem, just like we're going to think about this in the context of the problem. Can I buy 2.6 video games? No, I can't buy 2.6 video games, just like I can't buy negative 0.6 video games. I can't do it. So if I change this to be accurate to the context of the problem, this would be the most video games I can get. I can't get 3. The most I could get is 2. And then G, and then 0. So here you're looking at it money-wise of I can spend $100 or I can spend $0. I have that range. I can either spend no money or I can spend $100. That's the money I have to play with. I have a range amount of money to go spend at the mall or wherever, all right? This is a range of the amount of games I could buy. So I solved it for games. How many games can I buy? And it's anywhere between 0 and 2. I can buy 0 games and spend $20. I'd have $80 left over. I can buy 1 game and that would make me spend $50 and have $50 left over. Or I can buy 2 games and spend $60 because 30 times 2 is 60 plus 20 is 80 and have $20 left over. And $20 doesn't leave me enough money to buy another game because the games cost 30. So I can only buy up to 2 games. So both of these are fine. I would accept both of these. These both represent a different way of looking at the problem. This represents looking at it in the way of money, $0 to $100. And this represents it in the way of looking at it from how many games perspective. I can buy 0, 1, or 2 games. Both are acceptable. I myself need to go back into the answer key for my students and get both of these acceptable. I was looking just at this initial one, but I'm always exceedingly happy with when I see students go a little above and beyond and actually solve it out and look at it from the contextual standpoint of the scenario. But I'm going to end it there. So just a quick review to end this video off with. We got some very simple ones. There's some very simple ones where it's just obviously in between 2 numbers. We got some where it might be greater than or equal to or greater than, maybe just less than a number. We have some that are from a number to a number. So that works. That could be like a race of, like NASCAR 500, whatever, you can be on lap 0 to 500. So 0 to 500 laps. Stuff like that. And then we got the fishing boat capacity of you can have either 0 pounds of weight on the boat or 800 pounds maximum of weight on the boat. And we have this range of weight in between. And then in this context of the problem, we took 40 pounds with us of gear and solved for that of how many fishermen could we get on the boat. Realistically, not 4.75, right? You got to think about the context. Realistically, how many fishermen could we have realistically? How many games could we buy realistically? Not 2.6, not negative 0.6. We can buy from 0 to 2. There's no such thing as negative games. There's such thing as 0 games. You just don't have a game. And then 1, 2, 3, 4, 5. Okay. So I do hope this video was helpful. I hope I did not over explain anything. Yeah. So thank you for watching another video.